Question 10 is a very long question on binomial. It basically covers uh, uh, all the aspects of binomial. So for the first part, your job is to apply your basic expansion. So there is this formula that is given to you. This formula is actually found in the O-level formula list. So you should be able to execute the expansion. So if you couldn't, there will be another basic video to focus on the basic expansion. So see whether you can do a basic expansion. Okay, so part A1 is a basic expansion. A2 is also a basic method. The basic method makes use of the expansion that we have, and then we try to isolate the coefficient of x cubed. So how am I going to get the coefficient of x cubed? One method, some people, they will kind of expand out everything. They will expand out everything, and then they just go for the x cube. So if you decide to expand out everything, you got 8 arrows. So there are 8 arrows for you to simplify, and then later on you got to focus on the coefficient of x cube. So it's actually very tedious. If you look at the 8 arrows, not every one of them is going to give you the x cube. So you can observe first, this and this doesn't give me x cube. This and this also not an x cube. So this and this not an x cube. So if you have spent your effort for these 3, you realize that you are not getting x cube. But this one do give me an x cube. 1 times minus 80x cube do give you an x cube. So the previous 3 arrows is actually irrelevant. Then you observe again, is this an x cube? Is this an x cube? Yeah, this one looks like an x cube. Minus 3x squared and a minus 10. So that gave me an x cube. So the previous one doesn't. So let's go on and explore some more. Is there an x cube? X squared and x squared is actually an x4. X squared and an x cube is actually an x5. So out of the 8 arrows, you realize that there's only 2 arrows that can give you x cube. So you add the 2 arrows. So the red arrow will be 1 times minus 80. So you get the term first. So 1 times minus 80. Then the green arrow will be minus 3x squared times minus 10x. So you simplify first. So you will get a minus 50x cubed. So the one that we want is the coefficient. So this is what I will call an arrow method. The arrow method is a very generic method. So there's also a video to do a more thorough explanation on this idea. Okay, part B is the general formula. It is a general formula and it is a constant term. So if we are targeting a specific formula, we will use a general formula. So the general formula looks like this. So you're supposed to be able to decide your A, your B, and your N. And then you plug inside. So at the end of putting it in, you should isolate the constant. So I will not go through how I actually got here. So there will be a separate video on the concept of this. So what you should achieve from the general formula will be, you must be able to see the coefficient part. So this coefficient part has no x. So this is the x part. Then you target the power of x. So you got to know what is the power for constant term. So for constant term, sometimes they call it the term independent of x. Independent of x means there is no x. It's just a number. So when it's just a number, it's actually a coefficient of x 0, meaning the power of x is actually 0. So this is something a lot of students will forget. So that means, right, for constant, the power should be 0. So where is the power of x in your general formula? So this part is the power of x. So you set the power of x to 0, you will get an R value. So if you put the R value here, so you will get the constant term. And in this case, the constant term is equal to 7. So from here, you solve for your Q. So the general formula part may not be so easy, but the purpose of the general formula is to be able to see the coefficient component and the x component. So there's a separate video on this. If you need to, you let me know. Okay, this one is it's an O-level question. It was a very, very long O-level question. So a lot of students couldn't do it, and it marries a little bit on the idea of proving, like trigo proving. So you got to read very carefully the first 3 terms of the binomial expansion. So first term, second term, and the third term. So these are the first 3 terms. And the question says that the first 3 terms are denoted by PQR. So what does that mean? That means this is assigned to be P. This is assigned to be Q. This is assigned to be R. And you need to prove this. So this is like left-hand side to right-hand side. Okay, so if you need to do this, right, you actually need to know one set of formula. You need to know that this is N. So there is a set of formula on this. So the bottom part is 2 factorial, which is a 2. So P is equal to this. Q is equal to this. R is equal to this. It looks very complex. So I'm going to execute my left-hand side. So look carefully at my left-hand side. My left-hand side has a Q square. So how do I do a Q square? That means this whole thing will be squared. The bottom part is P and R. So I'm going to multiply these 2 big chunk of thing. So it looks very complex. It ends up more like indices. Okay, I'm going to show you. So if I square the numerator, I get a n square. I get something like this. I square everything inside. If I'm multiplying in the denominator, I saw a same base. I saw a same base multiplication. So I can be adding these two powers. You realize you can actually cancel this part. If you check out the proof, eventually all the A and B will disappear. So, okay, let's try to simplify a bit more. So after you cancel the B square, you realize that this also cancelled. So you are just left with this, which is n squared divided by a fraction. And that is n squared times, you do a reciprocal and you cancel. So that's how I've shown it. So this is quite high level and usually it's very confusing. So you might even need to relook after understanding the procedure because there's a bit of proving involved. So look back at this whole question, it actually summarizes, tests you quite a lot out of binomial.